Hello guys, and welcome to another session of Excel for Work, our virtual training program to help you work smart and increase productivity at the office. In today's session, we'll be looking at a very important topic in Excel, logic functions. Logic functions are basically functions that require a true or false statement in order to give you a result. In this session, we'll be looking at the most popular logic function in Excel, the if statement. So switch with me to the application sheet and let's get started. So logic functions, like I said, are functions that require a true or false statement in order to give you a result based on the outcome of the true or false statement. In this case, the true or false statement is the logic statement or the logic test. So let's take, for example, a simple if. So simple if requires or runs on one logic or one condition, returning just two outcomes, either a true or a false. These are the only two outcomes that can come out from the logic statement. So the first thing is to give it your logic tests, and then based on the true or false outcome, it's going to give you a value if true or a value if false. Okay, now logics can be created in two ways. Either you use the comparative operative signs we know, that's equal to, less than, greater than, less than, equal to, greater than, equal to, or not equal to. Or you use what we call Boolean functions. So Boolean functions like is number, is error, is even, is odd, etc. These functions will test a value based on these logics, and then if they actually pass that logic, it's going to give you a true, and if they fail that logic, it's going to give you a false. So those are the two main ways you can create logics in Excel. Either use the operative signs or use a Boolean function. So let's take an example. Okay, so over here we have a list of individuals, we have their scores, and we want to provide a remark. Now it says if the score is 5 and above, I want you to remark a pass, otherwise fail. Okay, so what we are saying is you don't need to come and type here, okay, so for this guy is below 5, so fail. This guy is 5 and above, so pass, 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 and so on. Because what we want to be done is that we want a dynamic remark so that in case the value changes, the score changes from 3 to 7, this remark should update from fail to pass. Do you get it? Great. So how do we do this? First and foremost, we need to get our logic right. Now, what's the logic? The logic is that the score in D20 is greater than or equal to 5. That's the logic statement. So we are testing if that's true. So equal to the score is greater than or equal to 5. Now when we hit enter, we get a false because that's not true. That's not a true statement. Now when you copy this down, you're going to get true and falses based on the score compared to our 5. Okay, so this in Excel is a simple logic statement created by comparing the score, okay, to our threshold, which is 5, using a comparative sign. Okay, now this is only going to result in a true or false based on the value. Okay, now once we have this true and false, we can use the if statement, okay, to modify the true and false. So instead of having true and false, we can modify it to pass and fail using the if statement. So this is what I mean. I'm going to take these off, come back to this. So this is my logic. Don't forget it. This is the logic. I'm going to cut this. I'm going to start my if statement. So if, okay, and it says, so if, first thing is the logic test or the logic statement. I'm going to paste that statement I made over here. So if this happens to be greater than or equal to 5, now what do I want as my value if true? If this turns out to be true, what do I want as the outcome? I want a pass. So in double quotation because it's a text, pass. If it falls, what do I want? I want what? Fail. So in place of true and false, these are the outcomes I want. So I hit enter, I have fail for this. I can copy this down. And I have this. Okay, so what I'm saying is now if I change this to 7, I have a pass due to this. Great. So that's one way you can actually create a logic statement in Excel. Let's try for the other way you can create a logic statement in Excel. Okay. Now it says if the score is an odd number, increase by 1. If the score is an even number, decrease or reduce by 1. So now how do we test whether it's an odd number or an even number? Okay. Now, we can use a mathematical way where we can use a function mode, MOD, okay, which is short for modulo, but I'm not going to do that. I'm going to actually use a Boolean function Excel, okay, called is odd, So this is a function, is odd. That's a function I'm going to use. So equal to is odd, and I'm going to select my number, this. So it's basically going to test whether this value is an odd number or an even number, right? So I'm going to hit enter, and I have true. Okay, I'll copy this down. I have some true and falses. Okay, so this is generating my true and false. This is my logical test. This is my logic statement, and I can wrap this in an if statement to get the result I'm actually looking for instead of trues and falses. So I'm going to say equal to if, right? What's my logic? My logic is odd, and I'm testing this number if it happens to be odd. Close function for odd, and I'll bring a comma. Now, value if true. If this happens to be true, what do I want? Okay, so it says if the score is an odd number, increase by 1. Increase the score by 1. So I'm going to select the score again and add 1 to it. So if this happens to be true, if this happens to be an odd number, I want this. If it's an even number, reduce by 1. So select the number again, subtract 1. Enter. I have 4 for this because it's an odd number. Copy this down. Okay, I have 5 here because it's an even number. I have 7 here, even number. I have what? 5 here, even number, and so on and so forth. So you get the drift. So you can take a logic, okay, and based on the outcome of logic, you can pretty much do anything. You can write a formula, put a text, put a value. Okay, so you see in this case, we are using formulas, which is this plus this, and that minus that. Great. Okay, so with this an example, let's try some real life scenarios and see how it goes. So let's scroll down to activity. So this is an activity where we have company bonus. So case 1, case 2, case 3. These are the various bonuses we want to calculate. And then this is the data. So we have some HR data over here. Okay, starting from data employed all the way to salary. And these are the cases. We want to calculate the varying bonus cases based on these bonus statements. Okay, so first one, it says bonus of 500 is paid to full-time employees. Okay, so when you read a question, the first thing you need to do is identify the logic in this question. It says a bonus of 500 is paid to full-time employees. So what are we testing? We are testing whether the employment type is equal to what? Full-time. Whether the value here is equal to full-time. So that's my logic. So I approach it with that in mind. So if the value here equals to what? To bracket full-time. Okay. And you notice in typing time, I started with a small case. That doesn't matter. Okay, the criteria doesn't have to be the exact same case. Okay, but then the spelling has to be the same. I can't replace this space with a dash like this. This won't work. Okay, it has to be exactly the same thing, but the cases can be different. Okay, so if this happens to be equal to full-time, what do I want as my value if true? It says what? It says pay a bonus of 500 to all full-time staff. So value if true is 500. And then in the absence of, or if you're not a full-time staff, you get 0. Okay, so enter. I have 500. I'm going to select this. So shift down direction key to the very end. And then Control D. Okay, so you notice that base 500 to all those who are full-time. contract part-time do not get anything. Okay, so let's try on the second question. Second question says, bonus of 15% of salary is paid to employees whose salary is more than 6,500. Bonus of 15% of salary is paid to employees whose salary is more than 6,500. So the logic here, the test here is salary is more than 6,500. Okay, that's our logic statement. So I do an if. So my logic test, this salary is greater than, right, 6,500. Okay. Now, if this happens to be true, what do I want? I want 15% of salary. So I literally have to write it that way. So 15% of, in this case, is represented by a multiplication sign, which is the asterisk, salary. So this is the salary. So 15% of this. Other than that, you get 0. Okay. So this is how I write it. So if H81 happens to be the salary for this particular record, happens to be greater than 6,500, I want 15% of that. Other than that, I want 0. So enter. And because it's above 6,500, I get 15% of this value. And then when I drag this down, instances where it's not, I'm not going to get anything. I'm just going to get 0. Okay. Now, the reason why it's hash, just in case anyone is wondering, is because of the format I'm using. In this case, I'm using an accountancy format or normal format. Okay. So if I do a Control Shift tilde, right, it reveals the 0 I placed over there. Okay. I'm not using anything different. It's just different format. That's all. Okay. So third case, bonus of 5,000 is paid to employees who are not contract staff. Bonus of 5,000 is paid to employees who are not contract staff. So pause the video, give this a try, and let's see if you're able to get it. Okay, so let's do this. So equal to if, what's our logic? Our logic here is employment type, what is not, okay, so this is not equal to, so it's not equal to, less than, greater than, and it has to be in the exact order, less than first, then greater than next, then contract. So, okay, now what do I want as my value? So bonus of 5,000 is paid to those who are not contract. Okay, so I'm going to pay 5,000. Other than that, I'm going to pay 0. So a few things I want to mention over here. Okay, so you realize I wrote contract and not contract staff or contract employees. Okay, it has to be exactly as you have it in the column. Okay, so if it's contract you have over there, you have to write contract, right? Nothing else. That's the first thing. So I hit enter. I have 5,000. I can select this all the way to the bottom with my shift direction key and Control D to copy down. That's the first thing. Okay. Now the next thing I can also do is, another way to solve this is, I can also say if, okay, this happens to be equal to contract. You know, the question says if you are not contract, you get 5,000. But if you are contract, what do you get? So if this happens to be equal to contract, I can say, give me 0 as my value if true. Other than that, give me what? 5,000. So I have reversed the logic statement, and for that reason, I have reversed the value if true and value if false. I've switched them up because this logic has been reversed. The same thing. So once I have this typed, I can do, and I have my array selected. I just do a Control Enter, and I get the same thing applying through. So both of them works based on how you write your logic. You know how to arrange your value if true and value if false. Okay, so that's for the very first three. Okay, the next one says no bonus is paid to employees whose job rating is below 2, but a bonus of 200 is paid to employees whose rate is below 4. Finally, a bonus of 350 is paid to employees whose rating is equal to or above 4, right? So you realize that in this question, it's a bit different from what we have been doing, which is a simple if. For this question, we have different value if true assigned to people based on a certain logic they meet. So if you do not have a rating above 2. So if your rating is below 2, you get 0 as your bonus. If your rating is below 4 but above 2, you get 200. If your rating is above and equals to 4, you get 350. So a different value if true is assigned for every logic. Every logic has its own value if true. Okay, so this is what we call the nested if approach. Okay, so we're going to look at this using this question. So nested if is very simple. You're using two or more independent conditions which return their own value true, value false. So the first logic, you are going to assign its value if true. Second logic, value if true. Now, if the second logic happens to be the last logic, then you also assign the value if false. If not, you assign the next value, the next logic, and its value if true until you get to the very last one. That's for the nested if. So we can use a nested if, or we can use the newer function called ifs. Okay, so the ifs function also does what we call the nested if. It does the multiple independent condition approach, but then with that one, there's no value if false. Okay, so logic value if true, logic value if true. There's really no value if false for the ifs. So we'll look at both of them and we'll try and understand how they both work. Okay, it says the student scores 8 and above, remark as good. The student scores between 3 and 8, remark as average. Anything else is remarked as what? Bad. Okay, so let's first try with the if approach, which is the nested if. So equal to if. Okay, so our first logic, it says a score, if a student scores 8 and above, remark as good. So if the score happens to be greater than or equal to 8, what do I assign as my value if true? The value if true is good. Okay, that's a comma. Now you notice that for a simple if we'll be doing, what we're going to assign is probably bad for if the student doesn't score 8 and above. But here we have another score or another logic. So we need to state that logic before we can state the value if true for that logic. So another if. So if this, okay. So we've already covered for greater than or equal to 8. We've covered for all numbers greater than or equal to 8. So now we're looking at if the student scores between 3 and 8. So anything above 3, so greater than 3, okay. Right, so if the score happens to be greater than 3, we want to average. Anything else is marked as bad. So if you don't score equal to or greater than 8 to get good, and you don't score anything above 3 to get average, then you're going to get what? A bad. So that's how it's done. And I close bracket like this, and I close that. So if this is greater than 8, good. If this is greater than 3, average. Other than that, everything else, bad. So enter, and I have this. And I can copy this down, and I have this. So bad, average, good, average, and so on and so forth. So that's what we call the nested if approach, when you use multiple ifs for different logics. The newer function is the ifs, ifs, so ifs. Okay, so we have ifs, you state the logic and the value if true. So I state this is greater than or equal to 8. And in that instance, the value if true, this happens to be true, is good. My second logic is if this happens to be greater than 3, okay, my value if true is average. Okay, now I need to provide a logic for the next one, that if you don't get this and you don't get that, whatever you get, okay, the value if true is bad. Okay, so one way I can do this, I can say, so anything below 3 or anything 3 or less will give you bad. So I can actually say this less than equal to 3 should give me what? Bad. The reason why I have to do this is because the if statement doesn't have, like you can see here, you don't see what? A value if false. We have only value if truths. Okay, every logic and a value if true. So I have to provide actually a logic for the value if false, and I provide this. I can do this, enter, bad, and I can copy this down. Do you see this? Good. Another way I could have done this is instead of disturbing myself to write the opposite of this logic, I could have just placed true here, saying that anything else is true and therefore gets a bad. That also works. I can copy this down. So both of them works. Either I provide the opposite of this last logic, or I can provide just a true and then I state the bad. Any of them works. Okay, so those are the two approaches to carry out a multiple independent condition for which each of them have their own value true. Okay, so with this information, now let's go back to our question. Okay, let's read our question one more time. So our question reads, no bonus is paid to employees whose rating is below 2, but a bonus of 200 is paid to employees whose rate is below 4. Finally, a bonus of 350 to employees whose job rating is equal to or above 4. So realize that each logic has its own value if true. Okay, so we're going to use both approaches and see how we can get this done. So for case 4, over here, I'm going to use an equal to first the if statement, so equal to if. So if this, okay, happens to be less than 2, what do you get as a value? You get nothing. Okay, that's the first logic. I realize that there's another logic. It says, so in the value if false section, after bringing my comma, I bring what? Another if. This same value happens to be less than 4. What do you get? This time you get 200. Okay. Now the last one, which is the last logic, says if you are 4 and above, you get 350. Okay, so that means if you're not less than 2 and you're not less than 4, anyone else gets what? 350. So I can just bring a comma and says what? Anyone else gets a 350. So just put 350 over here, close this for my first if and the second one like this. And then I can hit an enter. And there I have it. Okay, so copy this down. And I have this. Okay, so that's the first one. Let me try carrying out the second one over here. So equal to ifs. First logic, this is less than 2, and for that reason you get 0. Now I don't need to repeat the if again because I'm using ifs. I just need to go ahead and provide a second logic, which is this. It's less than what? 4, and what do you get for that? You get 200. Okay. Now I need to provide a third logic. I can say that if this is greater than or equal to, which is the reverse of the very last logic. Other than that, I can put just a true here, which is much more preferable for me. So true, meaning that the logic returns a true, basically a true. So anything else is true, and therefore you get 350. Close this once, and that's it. Enter. I'm going to copy this down. And you notice I get the exact same result as using the if. Now the ifs is a much newer function, like I said. It's not available in all versions. So if you don't have the ifs, you can just use the normal if, which is the nested if approach. Okay, great. Let me take this off and let's move on. Case number 5. Bonus of 5,000 is paid to employees whose job rating is above 3 and has worked in the company for more than 10 years. So we have job rating and we have years in service. For those who have worked and have a job rating above 3, for example, this person and has worked for more than 10 years, so job rating is also greater than 10, they get a bonus of 5,000. Okay, so if your job rating is not above 3, but you've worked for more than 10 years, you do not get the bonus. So for instance, this person is not entitled to the bonus because even though they've worked for more than 10 years, their job rating is not above 3, like the statement said over here, above 3. Okay, so you realize that in this particular instance, 2 logics have to be met before you get a particular value if true. Unlike the other ones we've done, every logic has a value if true, or we just have one logic, then there's a value if true and value if false. In this case, two logics have to be tested, and then based on the outcome, you get what? A value issue. So that is the issue, and that is the scenario we need to learn at this point. Now, as it stands, the if function, if or ifs, can only test one logic for a value issue. They can't test more than one for a value issue. So we need a helper function, okay, called the AND function, AND. The AND function, AND. Now, this is for when there are two or more dependent conditions or dependent logics, like what we just read. You have to have a job rating greater than 3, and you have to work or have a years in service greater than 10 before you get a bonus of 5,000. So the AND function is a good way to get this done. So let's try and understand how the AND function works. So AND function. Okay, so the AND function, it can test one or more logic, and then if all of them are true, you get a value true, and if even one of them is false, everything is false. So let's take, for example, these calls. Let's say I want to carry out a test, okay, and I want to test and give a good if my value is greater than 5 and it's an even number. So if my score is greater than 5 and an even number, I want good. Other than that, I want bad. Okay, so let's first try and create a logic. So you realize that we have two logics. The first one is this is greater than 5, and the second one is this is an even number. So I'm going to use AND. Okay, so when you do equal to and first logic, second logic, and you can put a lot of logics in here. So this is greater than 5. That's the first logic. That's the first logic statement. And I bring a comma. Now this is an even number, so I can use this even. Select this number, close bracket. And realize both of them are going to result true and falses. This is a logic statement, this is a Boolean function, right? They're both going to result true and false. If I do F and F9 to test this, I get false for this one. If I select the first logic and I do F and F9, I get false. So false, false, I'm going to get what? A total false. I can copy this down. Okay, so you notice that I get false and some trues. Now over here, if I test this one, function fn or f9, I have true. Over here, true. Both of them happen to be true, true. Okay, and I have this. Now let me say if I had 7 over here, 7. So you notice that 7 is greater than 5, but 7 is not an even number. So then I get false. So 1 is false and everything becomes false. You get it? But if all of them are true, everything is true. Now the opposite or the variant to this is the OR function. The OR function. Okay. Now the OR function can also test logics, multiple logics. But for the OR function, just one logic has to be true for everything to be true. And everything has to be false for it to be false. So if I do equal to OR, and I select this is greater than 5, which is false, because this is 3, and then it's even, I select this number as my second logic. Okay, when I hit enter, I still get a false. Now when I copy this down, you notice for this instance, in the AND, it is false, but in the OR, it is true. Because here, this logic, Fn, F9, to test my logic, is true. Okay, while this, Fn, F9, is false. So because you're using the OR, just one of them has to be true for everything to result to true. Right? So that's how it works. So we have AND, we have OR. Now this functions test the multiple logics and give us the true and false that the if function needs to be able to operate. So with this in mind, we can now carry out what we're supposed to do. So case 5, it says a bonus of 5,000 space employees whose job rating is above 3, first logic, and has worked in the company for more than 10 years, second logic. So let's go. So equal to if, right? Now in place of our logic, that's where we bring our AND statement. So A and D. And the first is to say job rating is greater than what? 3. That's the first logic. Second logic is what? Years in service is what? Greater than what? 10. Good. Then we close an AND function. Then we bring a comma. Now what do you want if this happens to be true overall? I want 5,000. And if it's false, I want 0. Close this, enter, and select this and double click at the edge here. 1, 2. And I have this. Right? So realize just a few people qualify for the bonuses because you need to meet both logics to get this. Now let's try the second one. It says, which is the exact same thing, which says bonus of 5,000 is paid to employees whose job rating is above 3 or have worked in the company for more than what? 10 years. Right? So this time you don't need to meet both logics. You don't need to meet both conditions to get the bonus. If you meet at least one of them, so it's either your job rating is above 3 or you've worked in the company for more than 10 years. So equal to if or first logic, job rating is greater than what? 3. Second one, years in service is what? Is greater than what? 10. Close bracket. See this? So bring a comma. So what's the value if true? Value if true is 5,000 if this happens to be true, and 0 if this happens to be false. So I close brackets. Okay, hit enter, right? And I can double click here and have this. Great. So this is how you can use logic functions to actually assign values based on the outcome of the logic, whether true or false. I hope you're able to learn something. I hope you're able to add this to your list of Excel tricks. Thank you for joining us, and I hope to see you in our next session.
If this video was helpful and you would like to receive more of these videos directly on your WhatsApp, you can send ad to this WhatsApp number. We'll add you to our broadcast list so you receive our videos directly. You can also visit our YouTube channel, Finance Skills Hub. All our old videos are here. Please subscribe for notification of new videos or connect with us on any of these social media handles. Thank you so much for watching.